Right, for those that have just come out of proving identities, staying on. So, it's question 6. We've got a few graphs going on, and we haven't really spent that much time on graphs. So, we're determining this. It's such a small part, and it will, yeah. So, let's see. We've got f of x equals a cos x, and we've got g of x. Let's do that in green. So, g of x equals tan x minus p plus q. Now we've done some of these in the previous section. What does a do to our function? Stretches it. What does the minus p over here do? Move it left and right. And q moves it up and down. So those are translations and our transformation dilatation with a. Okay, so here we go. It's sketched between 0 and 315. Now we've got these asymptotes at 135 and 315. We know which graph that must be dealing with, right? Those are with our tan graph, because the tan graph is the one that has the asymptotes. And when we're drawing a tan graph, we generally drew those asymptotes first. So where are the asymptotes kind of normally in our, if I said y equals tan x, where are asymptotes? So if you drew that and you went, oh, there's our, that's not quite what a tan graph looks like. There's our tan graph, and there it is between 0 and 360. Where was this asymptote? Well, our asymptote, let's just see. When is it not defined? Now, I've moved that calculator because I got in the way earlier. So we've got here to say tan of 45, that was fine, that was 1. What other angles are interesting? Tan of 90, math error. In other words, it's not defined at 90 degrees. Now, you may or may not use your calculator. I just think it can be a useful crutch, so I've put it there. In other words, that's at 90. That one there is plus another 180. Or you remembered because that was halfway at 180 and it's halfway between there. The point is that this helps us know if it was at 90 and it's moved right by 45, then our p value must be 45. So p equals 45 because we've moved the asymptotes. If things have moved right, then it's x minus 45. Remember, it'll look like x minus 45. Okay, and while we're on the tan graph, the plus q means that it's moved up or down. While our tan graph normally goes here and moves down on the axis, whereas here we can see that is happening down by 1. It's going there, and then, am I speaking nonsense? No, I'm not speaking nonsense. Here we go. You can see that it's doing that curl down here. So, and it's doing it halfway between 0 and our asymptote here. So it's moved down. So what's our value of q then? And what's another way of looking at it? Maybe let's look at this point. Here we would have had in our tan graph y equals tan theta. It would have gone like this, and this would be 90. At 45 degrees we would have had 1, and at 0 we would have had 0, 0. Now everything's moved right, we said, by 45 degrees. So if it had just moved right, then this point here would have been, so this is our actual graph. If it had just moved, so if I just moved this graph right by 45, so it had gone here and then started going down, then wouldn't this point here, 45 being at 90, would have been at 1, and 45 would have been at 0. But as we can see from the graph that we're given, it must have moved down, and instead of being here at 90, it must have moved down. Let's do it over here. must have moved down by 1. So it's moved across by 45 degrees, and it's moved down by 1. So therefore our Q value is -1. It's moved down by 1. Okay, and our A cos x, in other words, we've taken cos x. In our head, we know that cos x goes, it's that one. So it's at 1, 0, -1. It's been stretched out. So let's see. It's going from this. It's still going between -1 and 1. But it looks like it's gone the other way around. So in other words, A must be -1. Okay, that was a whole lot because, I don't know, we're thinking quite a lot. Although, if we know what you're doing, you go quite quickly to go, well, this is the same amplitude. It's just been reflected. It's that -1, so we do that quickly. And for these moving left and right, we just go, okay, well, this graph, you can see it's moved. And we're thinking all of those, although we're not drawing it. So let's go into the next few questions. For which values of x is f of x greater or equal to g of x? What does the question really mean? We've got, which way around do I do this? G of x is green. So we've got g of x and we've got f of x. And we're asking, when is f of x, when is it greater than or equal to? So when is it above or equal to g of x? So let's see. When is the pink graph, a cos x, above the green graph? Well, here it is here and up to that point. So there it's definitely above. Let's fill that part in. And then to go from there, nope, it's below, it's below. Oh, no, for this part it's above because that goes all the way. So over there, and nope, stops being above. So this one carries on because, of course, that goes down there. Just say, so it's all of those sections. So we're going from 0 up to 90, from 135 up to 270. So we're going from, let's do it, let's go Marini. So we're going from 0 up to, where did we say? 90, right? And we're also going from 135 up to 270. Now, the maybe a difficulty in the question is, when do we include, exclude? Well, that looks like it's included. 90 said greater than or equal to, so we must include. 135, include or exclude? Exclude, because it's an asymptote, so the green graph doesn't exist. Tan graph isn't defined at that point, so we're going to exclude. 270, we're going to include. So for which values of x? Well, x is an element of those two. Don't worry about the element, the union. I mean, we're just saying those two. And okay, so write down the range of h of x. If h of x is -3 cos 2x minus 30 degrees plus 2. Whew, there's a whole lot going on here, right? So we've got this graph, and what are we doing to it? We're timesing it by -3. We're multiplying this by 2. We're subtracting 30, and we're adding 2. So we're doing a whole lot of things to this. So we want to know what the range is. Now, the range must surely be in the same given domain, if that matters. So -3. So remember, the minus is going to reflect it. It's not going to affect the range. The 3 is going to multiply it by 3. Cool. So then the range for this one was the y values, right? So it's going from -1 to 1. If we've multiplied it by 3, even if by -3, it doesn't matter. So it must have gone up. So in our kind of general just sketching, we're going, it was -1 to 1. Now with the -3, it's going to go from -3 up to 3. Cool. So that's that part. And then the last piece of the puzzle is, oh, it's adding 2. So if we plus 2 to that, then we're going to go from not -3 anymore. It's going to have moved up, right? So it's going to go -1 up to 5. So the range, yeah. And this affects the thing moving left and right. So it doesn't matter. It's still going to go between -1 and 5. Doesn't matter. It's moved a whole lot left and right. So there's our new range. That's going to be between -1 and 5 because of that. Cool. That was a nice, juicy way to end, right?